I'm glad here to study operations research with you. The textbook we'll be using is the Introduction to Operation Research by Hillier and Liverman. Today we'll start our first lecture, Introduction to Operations Research. The introduction consists of 4 parts: the origin, the nature, the impact, and the procedure of the operations research. First, we talk about the origin of the operations research. 2 problems exist in the modern organizations. One problem is the tendency for the many components of an organization to grow into relatively autonomous empires with their own goals and value systems, thereby losing sight of how their activities and objectives mesh with those of the overall organization. Another problem is that as the complexity and specialization increase, it becomes more and more difficult to allocate the available resources to the various activities in a way that is most efficient for the organizations as a whole. These kinds of problems and the need to find a better way to solve them provided the environment for the emergence of operations research, commonly referred to as OR. The root of OR can be traced back many decades, when early attempts were made to use a scientific approach to the management of organizations. The beginning of the activity called operations research has, however, generally been attributed to the military services early in WW2. Because of the war effort, there was an urgent need to allocate resources to the various military operations and to the activities within each operation in an effective manner. By the early 1950s, a growing number of people had introduced the use of OR to a variety of organizations in business, industry, and government. The rapid spread of OR soon followed. At least 2 other factors that played a key role in the rapid growth of OR during this period can be identified. One was the substantial progress that was made early in improving the techniques to OR. A prime example is the simplex method for solving linear programming problems, developed by George Dantzig in 1947. Many of the standard tools of OR, such as linear programming, dynamic programming, queuing theory, and inventory theory, were relatively well developed before the end of the 1950s. A second factor that gave great impetus to the growth of the field was the onslaught of the computer revolution. Second, we introduced the nature of operations research. Operations research means research on operations. Thus, operations research is applied to problems that concern how to conduct and coordinate the operations within an organization. Therefore, the nature of the operations research is OR uses an approach that resembles the way research is conducted in established scientific fields. The process begins by carefully observing and formulating the problem, including gathering all relevant data. The next step is to conduct a scientific model that attempts to abstract the essence of the real problem. Next, suitable experiments are conducted to test this hypothesis, modify it as needed, and eventually verify some form of the hypothesis. OR frequently attempts to find the best solution for the problem under consideration. Here we say a best instead of the best solution because there may be multiple solutions tied as best. Search for optimality is an important thing in OR. OR experts are a team to do all the things. OR attempts to resolve the conflicts of interest among the components of an organization in a way that is best for the organization as a whole. This is the viewpoint of cooperation. Next, we briefly talk about the impact of operations research. OR has an impressive impact on improving the efficiency of numerous organizations around the world. it has made a significant contribution to increasing the productivity of economies in various countries. There are now more than 30 member countries in the International Federation of Operational Research Societies, with each country having a National Operations Research Society. It appears that the impact of OR will continue to grow. For example, upon entering the 1990s, the U.S. Bureau of Labor Statistics predicted that OR will be the third fastest growing career area for U.S. college graduates from 1990s to 2005. It also predicted that 100,000 people will be employed as operations research analysts in the United States by the year 2005. Next, we talk about the procedure for operations research. The procedure of operations research basically includes these steps. First, defining the problem and gathering data. Second, formulating a mathematical model. Third, deriving solutions from the model. And next, testing the model, preparing to apply the model, and then implementation. Next, we'll talk about the details one by one. The first order OR team is to study the relevant system and develop a well-defined system of the problem to be considered. This includes determining such things as appropriate objectives, constraints on what can be done, interrelationships between the area to be studied and other areas of the organization, possible alternative courses of action, time limits for making a decision, and so on. To assert the appropriate objectives, a number of studies of U.S. corporations have found that management tends to adopt the goal of satisfactory profits, combined with other objectives instead of focusing on long-run profit maximization. Typically, some of these other objectives might be to maintain stable prices, improve worker morale, maintain family control of the business, and increase company prestige. Furthermore, there are additional considerations involving social responsibilities that are distinct from the profit motive. There are 5 parties generally affected by a business firm. First, the owners, such as stockholders who care about profits, such as dividends, stock appreciations, and so on. Second, the employees, who desire steady employment at reasonable wages. Third, the customers, who desire a reliable product at a reasonable price. The suppliers, who desire integrity and a reasonable selling price for their goods. And last, the government and hence the nation, which desire payment of fair taxes and consideration of the national interest. Second, gathering relevant data about the problem. For example, an OR study done for the San Francisco Police Department resulted in the development of a computerized system for optimality scheduling and deploying police patrol officers. The new system provided annual savings of $11 million, an annual $3 million increase in traffic citation revenues, and a 20% improvement in response times. In assessing the appropriate objectives for this study, 3 fundamental objectives were identified. First, maintain a high level of citizen safety. Second, maintain a high level of officer morale. Third, minimize the cost of operations. Second, we talk about formulating the model. The mathematical model of a business problem is a system of equations and related mathematical expressions. And related quantifiable decisions to be made are called decision variables, such as x1, x2, up to xm. The appropriate measure of performance is then expressed as a mathematical function of these decision variables. The function is called the objective function. Any restrictions on the values that can be assigned to these decision variables are also expressed, which are called constraints. For example, x1 plus 3x1 x2 plus 2x2 less than 10. The constants, namely the coefficients and right-hand sides in the constraints and the objective functions, are called parameters of the model. An OR model is often expressed as a function of maximizing a function z, which is a combination of all the variables x's and with all the constraints here. The mathematical model might then say that the problem is to choose the values of the decision variables so as to maximize the objective function subjected to the specified constraints. Next, we talk about how to formulate a mathematical model. Determining the appropriate values to assign to the parameter of the model is both a critical and challenging part of the model's building process. The value assigned to a parameter often is, of necessity, only a rough estimate because of the uncertainty about the true value of the parameter. To analyze how the solution would change if the value assigned to a parameter were changed to other possible values, we can do the sensitivity analysis. It is even possible that two or more completely different types of models may be developed to help analyze the same problem. For example, an OR study done for Monsanto Corp was concerned with optimizing production operations in Monsanto's chemical plants to minimize the cost of meeting the target for the amount of certain chemical product to be produced in a given month. The decisions to be made are the dial setting for each of the catalytic reactors used to produce this product, where the setting determines both the amount produced and the cost operating the reactor. The form of the resulting mathematical model is as follows. This model has over 1,000 decision variables R and its use led to annual savings of approximately $2 million. Next, we talk about how to derive solutions for mathematical models. Sometimes it's a relatively simple step, which can use the standard algorithms. Sometimes it is difficult. A common thing in OR is the search for an optimal or the best solution. Eminent management scientist and Nobel laureate in economics, Herbert Simon, points out that satisfying is much more prevalent than optimizing in actual practice. In coining the term satisfying as a combination of the words satisfactory and optimizing, goals may be set to establish minimum satisfactory levels of performance in various areas, based perhaps on past levels of performance or on what the competition is achieving. If a solution is found that enables all these goals to be met, it is likely to be adopted without further ado. Such is the nature of satisfying. Next, we talk about how to test the model. The process of testing and improving a model to increase its fidelity is commonly referred to as model validation. A systematic approach to testing the model is to use a retrospective test. When it's applicable, this test involves using historical data to reconstruct the past and then determining how well the model and the resulting solution would have performed if they had been used. Next is about preparing the model. After the testing phase, the next step is to install a well-documented system for applying the model as prescribed by management. This system will include the model, solution procedure, and operating procedures for implementation, and this system usually is computer-based. At the end, the implementation. It is important for the OR team to participate in launching this phase. The success of the implementation phase depends on a great deal upon the support of both top management and operating management. The implementation phase involves several steps. First, the OR team gives operating management a careful explanation of the new system to be adopted and how it relates to operating realities. Next, these two parties share the responsibility for developing the procedures required to put this system into operation. In conclusion, in this chapter, we only focuses on overall process of the OR. We have tried to emphasize that this constitutes only a portion of the overall process involved in conducting a typical OR study. In the rest of the class, we will focus primarily on constructing and solving mathematical models. That is the basic about OR. Thank you very much.